Hello, my name is Gavin Wheeler and I'm Regional Manager for Hobbs Valve, covering the north of the UK, the North Sea and the Americas. In this brief presentation, I'm going to talk to you about why you should utilise triple offset within your application, project or pipeline. If you look at the left half of your screen, you will see a standard concentric rubber-lined butterfly valve. As this valve is operated, it's in constant friction with its rubber liner. So in essence, it's always wearing itself out. The second illustration shows a double offset butterfly valve. With a double offset butterfly valve, there is reduced friction, and this is all down to shaft position, which I will explain in the later slides. The third illustration shows a triple offset butterfly valve, and what the triple offset offers is zero friction through its operating cycle. So, just to recap, you have a standard concentric rubber-lined butterfly valve where the disc is in constant friction with the rubber liner. The double offset offers reduced friction, and this is down to the shaft position, but still in its first or final 15 degrees of opening or closing, the disc has to deform a rubber liner to cause a positive seal. The triple offset, because of the three offsets which I will run through in later slides, offers zero friction through its operating cycle. Therefore, it would outlast any concentric or double offset butterfly valve 20, 30, maybe 50-fold, depending on application. The first illustration shows a standard concentric rubber-lined butterfly valve, where the shaft, as you can see, is located in the centre of the disc. Because the orientation of the shaft, the disc, through its 360-degree operating cycle, is in constant friction with its rubber liner. The second illustration on your screen shows a double offset butterfly valve. To allow displacement of the seat, the shaft is offset from the centre line of the disc seat and body seal, giving you offset 1. Offset 2 shows the shaft position is dropped off the centre line of the valve bore, creating a cam action. But still, in its first or final 15 degrees of opening or closing, the disc needs to deform a rubber liner to cause the seal. When I talk about the cam action, the easiest way for me to describe this is to picture an airplane door. We've all sat on an airplane where the pretty hostess opens and closes the door. And basically it's exactly the same principle with the double offset butterfly valve. So what happens if you picture the door as the butterfly valve disc? The disc off-seats itself, rotates through to 90, comes back in and pops back onto its seal, exactly like an airplane door. The third offset depicted on your screen is a triple offset butterfly valve. As you can clearly see, the shaft position from a double offset to a triple is exactly the same. So we still have the cam action and the airplane door analysis. The third offset is nothing to do with shaft position. It's the angle on our sealing components depicted in green. This angle is an offset cone, like a witch's hat, if you will. And this is what allows us to achieve zero friction all the way through its operating cycle. As soon as the triple offset is cracked at 0.001 of a degree, there is zero friction all the way through its operating cycle, and this is achieved by the third offset indicated in green.